let's go ahead and take a look at section 21E.2, which is called the chain rule. Now we are going to be skipping over 21E.1 because we want to just jump straight into differentiation of a particular type of function. So let's go ahead and take a look at what the chain rule is used for. It says the chain rule is used to differentiate the composition of two or more functions. Okay, so let's go back to this, which is what we were talking about before with the simple rules of differentiation, is what are the different operations can you perform with functions. So remember we said that we can multiply a constant to the function, we can add two or subtract two functions, multiply two functions, divide two functions, or take the composition of two functions. Now, we've already talked about how to differentiate this using the scalar multiple rule. Okay, we've already gone ahead and also learned how to differentiate the sum or difference between two functions. We've also learned how to differentiate the constant function as well as the power functions. Okay, so what we have now is we're going to look at how to differentiate composition of functions. So in other words, when you actually compose two functions. So that's what the chain rule is used for. So let's go ahead and jump straight into the rule. The rule says that if you have y is equal to f of g of x, and notice that this is the composition of two functions, then y prime is going to be equal to f prime of g of x times it by g prime of x. Okay, so what does that mean? That means that the key is to first recognize the composition. So the first thing, of course, that you need to recognize is when you look at the function, yes, it actually is a composition of two functions, then I use the chain rule. The second thing that you need to determine is what f and g are, f of x and g of x are. Because notice that you need to actually determine what f of x and g of x are so that you can actually go ahead and perform this here, which is the chain rule, in order to find out what y prime is. Okay, so let's just jump into an example here. And let's say, for example, that we have y is equal to 3x plus 10 raised to the third power. Now, of course, if you wanted to, you could go ahead and use the binomial expansion, and you can go ahead and take the derivative of each one of the terms using basically this and this as well as the power rule. And you could do that, but there's a much faster way, and of course, this is using the chain rule. Now, you have to be able to just take a look at this function and realize immediately, yes, this is a composition of two functions, and because of that, I can then use the chain rule. So, what are the composition, or what are the two functions which make up this function here? What is f of x, and what is g of x? Now, if I just take a look at this function here, now the g of x is actually going to be put into the f of x. So, what that means then is that I can go ahead and then say that this right over here, this 3 plus 10, is actually being put into another function, and that of course would be something cubed. So, if I go ahead and say that this is 3x plus 10, that's the g of x, because that's what's inside here of the other operation, which is of course cubing. So that means that the function f of x is going to be x cubed, and g of x is going to be 3x plus 10. Now, just imagine that if I was to go ahead and show f of g of x, that means that I would take g of x and I would put it into f of x. So wherever the x is, I would put the x plus 3x plus 10, and sure enough, you'd come up with this. So that's where the composition is. And that's how we can check to see whether or not we have the correct composition. Okay, so let's just go ahead, and now that we've established what f of x and g of x are, we can now use our simpler rules of this, the multiplying, the scalar multiple rule, the sum and difference rule, as well as the power rule, to go ahead and differentiate f of x and g of x. So if I differentiate f of x, I use the power rule. This is just going to be 3x squared. And if I use g prime of x from g of x here, of course I use the scalar multiple rule here of 3x, and that's just going to be 3. Right, because that's just going to be x of, maybe I'll write it, 3 times it by 1x to the 0. And then of course, 10, using the constant rule, is going to be 0. The derivative of that will be 0. So what we come out with then is just 3. Okay, given that, I can now go ahead and very simply determine what y prime is of this y here. Let me go ahead and do this in blue. So y prime is going to be equal to f prime of g of x. So I need to take a look at f prime, and I need to take g of x and put that into f prime. So I take this here, so that's going to be 3 times it by 3x plus 10 raised to the second power. And then I'm going to go ahead and multiply it by g prime of x. Well, g prime of x we know is just 3, so I multiply it by 3. And there you go. You can go ahead and simplify that further to just 9 times it by the quantity 3x plus 10 squared. Okay, let's take a look at one other example, a couple more examples maybe. Okay, here's another one for you. Let's say, for example, we have 1 over 2x plus 4. Okay, now I'm hoping that you can recognize that this also is going to be a composition of two functions. Well, you might say, how is that a composition of two functions? Well, if I rewrite it slightly differently to this, then I'm hoping that now you can see the composition of functions. So, of course, in this case, f of x is going to be x to the negative 1, and g of x is going to be 2x plus 4. If I was to go ahead and take f prime of x, this is just going to be negative 1x to the negative 2 using the power rule. And if I use the sum rule here, the scalar product rule, as well as the constant rule, then I know that this is just going to be equal to 2. So now I can go ahead and very easily determine again what y prime is. Following this rule here, it is f prime of g of x, so that's negative 1. G of x is 2x plus 4 to the negative 2, and then I multiply it by g prime of x, in this case, which is 2. Okay, and there you go. So if I multiply that out, I would come up with negative 2 times the quantity x, 2x plus 4 raised to the negative 2 power. Okay, let's take a look at another one here. What if we have something that looks like this? What about the square root, okay, of x squared minus 3x? Okay, now I'm hoping that you can see very simply what the composition of the two functions will be. I'm going to change the form again because I like to change it so that I can see the exponents. So x squared minus 3x raised to the 1/2 power. That's the same thing. Oh, okay. So what we have then is we have for f of x, we have x to the 1/2 power. G of x is going to be x squared minus 3x. So if I take the derivative of f of x, that's going to be 1/2 x to the negative 1/2. G of x is going to be equal to 2x minus 3. Okay, so there you go. Y prime, in this case, is going to be equal to 1/2 that, which is x squared minus 3x to the negative 1/2 power, times by 2x minus 3. Okay, and there you go. That's how you can then use the chain rule to differentiate any composition of two functions. So again, just to put everything together, the first thing is to recognize that you do have a composition of functions and rewrite it so that you can see the two functions and the composition of those two functions. And then you need to determine basically the derivative function of the two functions that were composed, and then use what we have here, which is the chain rule, to go ahead and come out with the derivative of the original function. Okay, so there you go. That is the chain rule. We finished this, and now we have this in our pocket. We're almost there to actually cover all the different rules to take the derivative of a particular function. Okay, good luck. Let's see how you do. Bye.